Students, welcome to Divine Public School. I'm your science teacher. We are learning chapter 12, electricity. Now, what we have learned last time was about resistance, that according to Ohm's law, V is equal to IR. When you take the ratio of V upon I, you will get the resistance, and for that this experiment is there. As what I told you, they keep on changing the voltage and keep on measuring the current. So as you know, they increase the potential difference, the current will also increases. They increase the potential difference, so the current will also increase, right? So that is how they keep on putting potential difference, and they finally get the current. But the question is, what they will do is, right? But the question is, what they will do is that when you take the ratio of V versus I, they will get, when you take the ratio of V versus I, they will get the resistance, and the value of that is equal. So that is how they will find out the unknown resistance join in the circuit. Okay, and when they plot a graph of V versus I, it is always a straight line. Okay, when they plot the graph of V versus I, it is always the straight line. So what matter is, what we can do here is, the next what we are saying is the resistance. The unit of resistance is ohm, OHM, and the symbol is omega, right? But now what we are going to see is on what factors does the resistance depend on? On what factors does resistance depend on? So we'll see resistance depend on what. What we are going to see is resistance depend on what. Okay, so for that they have taken an experiment activity here. What they say is, they first did is they put a nichrome wire, right, and a torch and a bulb, plug and a key and a connecting wires, and they complete the circuit. Okay, and now, so complete the circuits by connecting. Note that the ammeter reading. So then they note down the ammeter reading. Then they remove the nichrome wire, and instead of nichrome wire, they put a torch bulb of 10 watt. Right? Then they took a reading of in ammeter. So basically, what they are doing is they are putting different things on it, and they are finding the measure of it, the current, right, with the help of ammeter. Right? So they put it and then they find out the measure. Now next what they are doing is, now repeat the above activity for 10 volt bulb, and what did they see? In each one they will get a different current. Now that's surprise. Yes. Why? In each one, why did they get a different current? Okay, in each of them they get a different current. Okay, now when if they get a different current, what will happen and why it is going to happen? That why different currents we are getting, why we are getting different currents into it. So let us see the same thing here. So they said that in this activity the current is different for different components. Certain components offer easy path of the flow of electric current because other gives a resistance to it because of resistance. So basically the battery is providing the same potential difference to all, but the question is why those, why that it will not get the current. Now, why you cannot see the equal current in all? Because of the resistance offered by each of them is different. In some, as what I said, that the flow is easy, right? That's what, see, the motion of electrons in an electric circuit constitute electric current. Okay, but the electrons, however, are not completely free to move within a conductor. They are restrained by an attraction of the atoms among them move. Thus, the motion of electrons through the conductor is retarded by a resistance. Exactly. The component of a given size that offers a low resistance are called good conductors. So, what we will call a good conductor? The one which offered a low resistance. It doesn't mean they do not have a resistance. They do have a resistance. But when the resistance is very low, we call it as a good conductor, right? We call it as a good conductor, and conductor having appreciable right? Resistance is called a resistor, means it gives you a good resistance. You cannot see a flow of current very well in it, right? Though that one we call it as a resistor. Okay, so you hope you are getting what I'm saying. We are talking about resistor. Okay, we are talking about resistor, the one which provide very less resistance is called, we call it as, we call that as what? We call that as a good conductor. But the one which applies a low resistance, we call it as a good conductor, and the one which provide a good resistance is called a resistor. Okay, we call it as a resistor. So a component of identical size that offers a higher resistance is a poor conductor, and insulators provides a high resistance, and insulator provides the high resistance. Okay, so this is small thing you have to understand here, that what they are trying to tell you. Okay, clear? So this one small thing you understand very properly, you will get it, what we are trying to say. Okay, now what next we can say is, what next we are going to see is, resistance depends on how many things. So first of all, resistance depend upon, so for that they have taken an experiment. What they did is, they take a wire, they take a wire of 1 meter, they take a wire of 2 meter, they take a wire of 3-4 meter. So we are going to see about resistance, how does the resistance depend, and what factors does the resistance depend on. Okay, fine. So see, the first thing we have seen here in this activity is what? We have given nichrome wire, we have given torch, we have given 10-volt bulb. So for different components, the resistance is different. So my homework to you is today, think a little, when you change the material, what will happen? See, resistance is really important because that helps you to control the current. So resistance is not always bad or something, it is good also. It depends upon how do we see it. Okay, for example, you increase or decrease the speed of your fan, think how. Okay, in your oven you increase the heat, that is also resistance, right? uh, Anywhere where you can see even the knob of a volume in your loudspeaker, that is also a resistance. So think, that is your homework, that how does resistance apply in all the places. Tomorrow I'm going to teach you very in detail about more in resistance with some activity. Okay, fine, thank you so much.